Here. We will start in 2 minutes more. Gracias por estar. Vamos a partir en 2 minutos más. La transmisión conjunta con YouTube.
Hola, bienvenidos a todos y todas. Más adelante pueden dejar sus preguntas en el chat.
La transmisión conjunta con YouTube.
Ahora sí.
Bienvenidos a todos y todas. Más adelante pueden dejar sus preguntas en el chat.
Sorry, I had the YouTube open, so it was the delay from the YouTube coming. At least I see 2 linguistics in the public. So José Manuel, thanks for being here. A Leonardo. Hola, Leonardo.
Hola. Bonjour.
Hola.
Ça va.
Mucho gusto verte.
Mucho gusto.
Yeah, Leonardo helped me advertising the talk in LinkedIn, so thanks, Leonardo. Okay, so I will start because I will give a 5 minutes introduction before the talk. Y voy a hablar en español porque Aurélie entiende español, ¿ya? De todas maneras, las preguntas las pueden hacer en este chat de Zoom o en el chat de YouTube. Y ambas las pueden hacer en español o en inglés. Si hay algo que traducir o algo que ayudar, yo puedo hacerlo. Pero sepan que Aurélie puede entender si hay una pregunta en español. Y cualquier cosa la traduzco. Entonces, quisiera partir como dándoles la bienvenida y agradeciéndoles por estar acá. En tiempos de pandemia a veces hay demasiadas cosas pasando y no todos podemos ir a todas las charlas que se dan. Así que muchas gracias por haberse tomado el tiempo de estar en este Data Days de 21 de octubre. Entonces, primero contarles que hay y han habido otros Data Days. Antes eran en vivo y eran muy entretenidos. Había comida, había conversación, había café después. Así que espero que volvamos algún día a ese tipo de eventos. La gracia de que sean online es que también podemos tener un invitado internacional que quizás nos costaría más traer a Chile. Así que los invito a revisar la página web de los Databases y como está en el chat escrito, la idea de estos Databases es conectar la industria y el público general con temáticas que tienen impacto en el país y en el mundo. Así que los invito a mirar la página web, ahí están todas las grabaciones también de los Databases. Así que si alguien se perdió alguno, puede revisar. Entonces, una bienvenida al Centro de Modelamiento Matemático. El Centro de Modelamiento nació en 2020, es el 2000, perdón, y ya fue recientemente renovado por 10 años más, perdón. Y es un centro que está albergado en el Departamento de Ingeniería Matemática de la Universidad de Chile, y además es una unidad mixta del CNRS, el Centro Nacional de Investigación Científica en Francia, que es el centro también donde pertenece Aurélie. Entonces, la misión del CMM es entregar investigación y enseñanza avanzada de matemáticas aplicadas. De nuevo, ahí está el link del CMM. Y en particular, la charla de hoy es acerca del procesamiento del lenguaje natural. Y nosotros tenemos un grupo de procesamiento del lenguaje natural en el CMM, que está compuesto, en nuestro caso, porque trabajamos mucho en texto clínico, compuesto por gente tanto de medicina como de salud. Y una de nuestras motivaciones es la creación de recursos lingüísticos y modelos computacionales para el análisis de texto en español. Y en nuestra página, en Resources, pueden ver todos los recursos que hemos liberado a la población. Así que los invito a mirar eso. Y hablando de compartir y crear recursos, hay un artículo que es muy fundamental para nuestro grupo, que es de Aurélie, y habla de cómo hay desafíos y oportunidades para el procesamiento del lenguaje natural en idiomas distintos del inglés. Así que, bueno, ahí, esta presentación se las voy a poner en el chat por si alguien quiere revisar en particular estos artículos. Y en términos de qué estamos haciendo en nuestro grupo, el proyecto principal es el corpus de la lista de espera anotado con consultas médicas y dentales. Entonces lo que nosotros hacemos es tomar interconsultas y anotarlas, lo que aparecen acá con banderitas, y hacemos desarrollo tanto en la creación de los recursos lingüísticos como en los modelos. Y en particular estamos trabajando fuertemente en este tipo de cosas que aparece una entidad dentro de una entidad más grande, que se llaman entidades anidadas o nested, y este artículo ya está publicado y está por salir. Así que eso es lo que nos hace nuestro grupo, y si alguien tiene alguna duda con eso, siempre nos pueden preguntar. Y por último, estamos enfocados no solamente en detectar las enfermedades, sino que asignar códigos del Código Internacional de Enfermedades, por ejemplo. Así que con eso quiero presentar, estoy muy contenta de que Aurélie haya accedido a dar esta charla. Aurélie pertenece al LISN. Ahora ya no se puede pronunciar, before it used to be LINSI, and now it's LISN, el laboratorio LISN,
we call it LISN, yes.
For Interdisciplinary Numerical Sciences. Aurélie has a master in linguistics and a PhD in computer science. She was in the Library for Medicine in the United States for many years, and now she's a researcher CNRS in this lab. So with that, I let Aurélie to start. And thanks very much to everyone.
Well, thank you, Jocelyn, for this very nice introduction. So I'm very happy for this opportunity to talk to you today about some topics that I've been quite interested in over the past few years. So thank you for inviting me to talk about this. So today I want to discuss ethics and reproducibility in biomedical natural language processing. So first, I want to say a few words about how I got interested into these topics and what has been my path towards this presentation, essentially. So last year, the Association for Computational Linguistics has adopted the ACM Code of Ethics. So after some discussions about ethics in the natural language processing community, and discussing these issues, and I was a member of the ethics committees that were held during the EMNLP, NACL, and ACL past conferences. And I also have a long-standing interest in reproducibility in clinical NLP through the organization of shared tasks, and I also did some surveys and literature studies to better understand reproducibility as it is studied and how we can effectively do it with our work for clinical NLP. And another point that is also quite important in my research is the accessibility to clinical corpus in French, or the lack thereof, in fact, because also of privacy issues. And I think you're facing the same so the same issues for Spanish and other languages other than English. And so first, I'm going to be discussing ethical considerations about research in clinical NLP. And so some of the discussions in the NLP community around responsible science have been going around an opposition between the notion of gatekeeping, so the idea that ethics principles are actually just going to be some kind of hindrance for researchers trying to enforce more rules than are really useful for moving research forward, versus trying to actually guide the research that we are doing. And so, in particular, the ethics committees there have been welcomed with a bit of apprehension in this respect. And so I'd like to talk about these issues with the approach that actually ethics are helping us do better research, and that ethics committees are a way to help us understand this ethics issue and to find ways to integrate them in our research throughout the entire research process. And so that's why I want to start with showing you a representation of what I see as the research process in biomedical natural language processing, where we have different phases, including modeling or designing a particular task that we want to address. And so that can involve defining a task with modeling in corpus. So by creating some annotations in corpus for tasks such as name entity recognition, as the examples that Jocelyn showed us for the Spanish referral corpus. So there's a modeling task, and then there's a part where we're going to be designing methods and applying these methods on corpus to evaluate the algorithms that are designed to address the particular task. And then there's another part where there's interaction with the community, and specifically the clinical community, to understand what kind of applications they need from natural language processing, how the existing tools can be used in clinical practice. And then this can go on in a sort of virtuous circle where we learn from the community, we try to design tasks that are going to address the needs that they have, and we design methods that are going to help solve these tasks, and so on. And so around these three aspects, we have to consider ethical questions, such as preserving the privacy of patients, for instance. And we have to also try to ensure the reproducibility of the different methods and tools that are developed. And we also have to think about the impact on the community of these solutions. And so in this respect, we can think of ethics as a nuanced discussion of at least three aspects of research problems that are intended to help us strive for better research as we iterate through these various aspects of the circle of research design. And so the three aspects are problem system design, then thinking about ethics in the data and the methods, and the impact on the populations that are going to be using the tools or impacted by the use of these tools, and the environment as well. So I want to go through each of these points to provide more insights on what these issues entail. And so I also want to situate this in the context of so early discussions and early work on the social impact of natural language processing by Spruit and Hovey, dating back to 2016, where they also so came up with a number of issues that they thought, ethical discussions that they thought should be talked about in the NLP community. And that can also fit into these three categories of design issue, data issues, and impact issue. So one notion is what they called overexposure. So it's the fact that there's an imbalance in data and in the problems that we are seeing, and so that creates that can create human biases. And there's also the notion of overgeneralization, which means that also because of data imbalance, we are so often confronted to the same types of problems or problems that are related to the same limited number of social categories of people. And by that, so we tend to conclude that so this applies to everything. So one example is that in NLP, there's a lot of work on English. So there's overexposure to English as the language that is being addressed by the work. And then an example of overgeneralization can be to think that methods or problems that are relevant for English are going to apply to other languages as well, or be relevant to other languages. And that leads to bias confirmation and also to the lack of seeing problems that are relevant only to other languages. And so that's what can be seen by looking at data. So there are problems linked to exclusion. So where, for example, certain social groups are absent from training data, or particular languages are not in the training data, so they cannot be addressed. There's also the issue of underexposure that is very related, where most resources focus on a few languages or a few types of problems. And then in terms of impact, they raise the notion of dual use, which is when NLP tools are used at the same time to address a problem, but can be also used to reinforce this problem. So if we look more at problem design. So when we address a research question, we need to think about whether the problem is meaningful and well designed. So here you can see an example of an experiment that I read about in general news. And so that's an experiment that was proposed by, I think, a company in the greater Paris area, where they thought they wanted to try to use a cloud-hosted language model to test GPT-3's abilities to provide chat service for appointment taking with patients, so in a biomedical context. They also wanted to have this kind of automatic chat facility to provide mental health support to patients and to provide medical diagnosis and so on. And so if we look at this kind of experiments, before going into it at the design stage, we can already see that there are a number of relevant questions that should be asked with this. So the fact that the model is going to be hosted on the cloud, it means that somehow data access should be carefully controlled, and there's a need to think about that at the design stage. And then we also need to question the impact of these proposed solutions on the different people that are going to be impacted, and in particular patients. So typically it may seem that having some kind of chatbot for taking appointments with patients is not something that directly impacts people's health, so it might be accessible, it might be acceptable. But we also need to think about the situation of the patients and whether they actually have the skills and means to access and interact with this kind of interface, etc. And so a number of similar issues that are generally related to machine learning in healthcare have been described in the paper that you see referenced here, and that allows to continue this discussion. And so more generally, when trying to address a problem and trying to think about the design, one of the things that is important to consider is who is contributed to design decision, and in particular, whether the design team is inclusive of all stakeholders and of a diversity of profiles. So to make sure that all the different perspectives are included. And also, it's important to understand power balance and conflict of interest, typically between different types of stakeholders. So including system designers, funders, users, patients, who might be patients, for instance. One thing that is also very central to biomedical research is the notion of human subjects. And so when we conduct research with natural language processing, we sometimes do not clearly see that how human subjects are involved in the research, and it's sometimes a bit difficult to understand when and how to interact with ethics committees or IRBs. But so one important thing to remember is that language involves humans, the humans who are producing the language. And so we need to think about the privacy issues with the content of the corpus sources that we are working with, and the potential harm that can result from using this corpus for the people who are involved, and also including in the analysis and processing that is done of the content of the corpus. So including some essentializing identity characteristics, and that can occur, for instance, when gender is used as a variable. So when you're trying to yield some categorization from text, so the very nature of the categories that are considered can have an impact on actually defining populations, and so there's a need to be careful with how this categorization is created and what it's used for. And during corpus processing, which often involves some kind of annotation of the text. So it means that there are again people involved in this process. So as workers, so when annotators are hired to analyze text and create annotations for analysis or for the preparation of corpus for machine learning solutions. So we need to think about the fair treatment of these annotators as research participants. And there's also the need to consider the impact of the exposure to clinical text on these participants as well. And finally, there's a need to consider the impact of the downstream users of the corpus, so including direct and indirect impacts. So the second part the second aspect that is important for ethics is the ethics regarding the data and the methods of research that are used. One important aspect of data is that even if we have very large data sets, they are often imbalanced and prone to bias. And so this can lead to different types of issues. So including differences in the way data pertaining to certain categories of people are processed, and also so the algorithms that are developed on biased data can not only reflect the bias that is present in data, but actually amplify it. So there's a need to be aware of the data content and the impact that it's going to have on the different algorithms. And so there's a number of studies that looked at these things. So in particular, there's a recent one published in JAMA that looked at the use of social media posts for the detection of influenza in social media. And so what they found, so this was conducted for American English, and what they found was that in the end, the extraction of information regarding influenza was yielding better performance for standard American English versus African American English. So thereby having a different impact on different social categories of people. So at the stage of dataset and corpus development, so these are things that can be taken into account by adequately describing a corpus and trying to, if it's, so it's never going to be possible to have a data set that is perfectly covering every single aspect of human language or a problem that one wants to study. But it can, if it's documented properly, then it can be used in a better way that accounts for these design features. So including the provenance of data. So being careful with the terms of use, so including confidentiality. And it's also important when creating data for future use to recall that some types of information is always sensitive. So depending on the analysis that is going to be carried out on the data, there's different different things to consider. And as I said, so describing the data sets very carefully in terms of the language, the size of each of the different splits, if there are, the selection and collection method for the data, and quality assessment that was conducted is helpful to understand the content of the data and how it should be used. There's also an important impact of the data on the kind of evaluation that can be done. So a recent study looked at the impact of similarity between training and test corpus on 4 different benchmark data sets for biomedical English. and they compared the performance of named entity recognition systems for these four benchmarks by varying the level of redundancy in the data between the training and test corpus. And so they find that this actually provides a very interesting insights on the reported performance of algorithm. And so they provide a characterization of what they called memorization, which is the fact that the algorithm is able to repeat something that was already seen in the training set, versus generalization, which is the ability to infer new information on data that was never seen in training data. And so there's a question in practice, which is always to understand how realistic is the application of a given method in a real life setting, and how can you anticipate how an algorithm is going to adapt to unseen data. And so I personally think it's also a very interesting research perspective there to with respect to what's called domain adaptation, to try to anticipate how an algorithm is going to behave with respect to unseen data by trying to analyze the comparability of the data that it was trained on, that it's seen, and the new unseen data. And finally, so this is a small illustration of what can be the impact of deploying natural language processing applications in a real life setting. And so this is a tweet from a British doctor about the result of an application which is providing some recommendation to patients about what course of action they should take based on a short description of their symptoms. And so in this case, the app advises the patient to consult a doctor when the doctor actually sees this as a medical emergency, and their advice would be for the person to immediately seek medical attention in the emergency room. So that's something that is really important. What kind of supervision is envisaged for the applications, and in this case it can be a life or death decision. So another type of impact that can be taken into account is the actual impact on the environment, because modern natural language processing methods tend to use very heavy deep learning methods that are using quite a lot of computer power. And so there was a study a couple of years ago showing the equivalent emissions of training NLP models compared to so everyday life actions. And so that highlighted how high the impact of NLP methods can be. And actually, these estimations are even an underestimation, because it only accounts for the impact of computer usage when the computer is actually used for training the models, and not for the entire life cycle of the computer equipment, which includes so building the hardware and then recycling it after it's no longer in use. And so more specifically, if you're interested into these aspects, I encourage you to look at tools that can help you understand impact of your experiments. So I give here an example of a couple of tools, but we conducted a recent survey to try to understand which tools are available for doing these computations. So we found 6 tools in total, and we showed that again they only provide an estimation of the impact of the actual training of algorithms as opposed to the complete life cycle of equipment. So it's just a part of the impact that is documented with these, and and we also looked at the measures that the tools provided for named entity recognition experiments, and the different tools for the exact same experiments for the same algorithms provide also different values, and so we need to study into more details why the tools are measuring things differently. So that's not actually a solved problem, trying to evaluate the impact of experiments. And another interesting result from this study is that the tools that have the higher environmental impact are not always the ones that provide the higher performance in terms of precision, recall, or F measure. And so that ties back to another discussion about trying to assess the performance of NLP methods beyond what's called leaderboard performance. So by taking account other aspects into the benefit risk analysis, so including environmental impact and maybe usability of solutions and their impact on end users. So now I want to talk a little bit about reproducibility. And I want to present the challenges in reproducibility. So in the past few years, so there's been a report of a reproducibility crisis in many disciplines. And so in 2016, there was a poll that was conducted by the Nature journal, where they looked at different disciplines, and they asked many scientists if they were, what was their experience with reproducing their own experiments or with reproducing other people's experiments. And overall, these figures were actually not very high. So in 2019, a group of us conducted a similar survey with NLP researchers to understand what the situation was in our field. And as you can see, it's actually quite similar, where the results show that it's actually non-trivial to reproduce other people's experiments, but also one's own experiments. And so before going further into this, we need to wonder, so first, what does it mean to reproduce an experiment? So there's different levels of reproducibility. And so these have been named differently in the literature. So I'll choose to use the vocabulary that you can see here, where repeating an experiment means that you're using the exact same hardware, software parameters, and data or method that was in the initial experiment. So it's a sort of deterministic reproduction experiments where everything is the same, so you expect to have the exact same results. Then replication means that you are reproducing the experiment using the same software parameters, data, and method, but with different hardware. So that can be, for instance, the fact of reproducing somebody else's experiment in a different lab, for instance. So that can tell you how robust the initial experiment was. Then when you're reproducing an experiment by using the same data or method, but with different hardware and software, then that tells you something about the portability of the initial experiment. And then there's the case of reuse, where a number of things are different, and that's aiming at looking at the generalizability of the task. So one thing that we can say for the biomedical community is that we have actually been using some methods that are very good at fostering reproducibility. So with the model of shared tasks, where these shared tasks have the primary goal of providing a forum for directly comparing researchers' approaches. And the shared task material makes available to the community a specific definition of a task, an instantiation of this task definition through annotated corpus that is split into specific training, development, and test sets. And it also supplies an evaluation metric and scripts. And as well as at the time that the task is initially run, the same hardware for doing the computation of all the participants. So when people are later reusing the material from the task, they often do not have access to the same hardware anymore, but it's still a strong setting for fostering reproducibility. And so at one of these shared tasks called Clay eHealth in 2016, we suggested to participants to submit their system. So in addition to submitting their results on the test set, they could also submit their system, so that a group of analysts, including people from the organization committee of the task, could try to replicate the results in their usual work environment. So we were in the second line of this table here, where the hardware was different, but we were going to be using the same software, data, and methods as participants. And so we thought that this was going to be easy. So we assessed the replication by having a score sheet with documentation of how we installed the software for replication, how we ran the software, the results that were obtained, and we timed everything. And what we found was that results were replicated in the end, but actually no single person was able to replicate all of the systems that were submitted. So just because we had different work setups, and there was not compatibility between all of the systems and one person's setup. And the time to replication was actually varying greatly depending on the system. So this illustrates the general notion that replication is possible, but it's not trivial even in a very controlled environment. And to help with replication, we need to dedicate actually lots of resources to it. So authors need time essentially to produce documentation that goes with the systems, and for analysts who are replicating the study, it also requires quite a bit of time and resources to understand what was done in the first place and to redo it. So recent survey took a broader look on reproducibility in natural language processing, and so they looked very specifically at the target of the replication, which is to get the exact same result as the first iteration of the experiment. And so they find that it's sometimes achieved, but not always. And some of the obstacles are that data and code are still quite elusive for replication. So recently, so through a collaboration with the French Paris Hospital, we tried to think about ways to increase actional reproducibility in clinical NLP to help with carrying so prototypes from so research prototypes into hospital operations, and to address the need for standardization and traceability of experiments. And we try to leverage expertise across different disciplines to review reproducibility criteria that had been expressed by the communities of bioinformatics, medical informatics, and natural language processing. And we use these criteria to characterize clinical NLP tools with respect to reproducibility. And so our literature review identified a number of articles that were providing some guidelines with respect to reproducibility for tools and workflows, so those mainly from the bioinformatics community. And so in the end, we came up with 40 different reproducibility criteria that can be divided into 5 big groups. So regarding the shareability of material, the traceability of experiments, the versioning of tools that are used, as well as resources such as the UMLS, standardization methods, and usability of tools and workflow for replication. And so one important point in this category is the absence of manual steps. So trying to avoid ad hoc tailoring of data or workflows. And we then evaluated the reproducibility of clinical NLP systems using these criteria. And so the systems that we selected were of 3 categories. So some on the left-hand side that are so popular clinical NLP systems relying on frameworks such as WIMA or GATE. So all of these systems are systems that are available for English, because we didn't have such tools for languages other than English to evaluate. So the ones in the middle are based on workflow systems such as Galaxy. And we also had an NLP toolbox relying on Python libraries. And so what we found was that so all of these tools do meet some of the criteria for reproducibility, but there's quite a bit of room for improvement, especially with the traceability of versioning and the shareability and standardization aspects. And so the experience from bioinformatics suggests that having modular components assembled into a workflow can also help with these aspects. And so our colleagues at the Paris Hospital proposed a workflow management system for French clinical NLP that can integrate a number of components of clinical NLP workflows, so including clinical data sources, data visualization aspects, and data transformation modules that can extract in the end information from text to populate clinical databases within the hospital. And so so one last aspect that I want to discuss, and that is fundamental to reproducibility in clinical natural language processing, is the ability to share clinical corpus in languages other than English, because to validate a particular pipeline, there's a need to have corpus that can be shared so that the pipeline can really be reproduced to make sure that everything is working as anticipated on a particular corpus. And so what we can see is that there are very few corpora available for languages other than English. So there's the corpus of patient referrals for Spanish that you know well. There are some corpus for death certificates that are shared by the authorities and that were used in the telehealth shared tasks. And so to address this lack of shareable corpus, there's been a number of creative solutions explored by the NLP community, including the development of synthetic clinical narratives and the use of clinical case reports for typically French and Spanish. And one important aspect for sharing data is the identification, which is the task of marking direct identifiers in text. But even though there's been a lot of work on this aspect and some very good results for this task, it's still different from anonymization. And so the question of whether text can be anonymized is currently remaining open. So now quite a bit of research is going towards the creation of synthetic corpus, as it's been shown that this synthetic corpus can really help to either augment real data or substitute real data for training clinical NLP systems. And so, so in the interest of time, I'll jump to the summary now. And so I hope that in this presentation, what I wanted to say was that ethics offers guidelines to question research motives, methods, and data, as well as the impact of methods, and discussion in the community and discussion through ethics committees can also help to think about these issues and to get guidelines about specific research projects in this respect. As tools are developed, it's important to make sure that they are compliant with reproducibility criteria. So reproducibility is complex and hard to achieve, but we have to keep trying doing it, and it's very important to document things. And to help with reproducibility, we also need to broaden the scope of shareable clinical corpus. So thank you. And if there are, I'd be happy to answer any questions.
Thanks, Aurélie. So, is there someone that I see a question in the chat? I don't know if David, you want to read it, or?
I don't know if I should switch over to the chat. Where is it?
Yeah, it is. Do you see the chat?
So I see. So someone is asking how, okay, how can reproducibility be improved? Okay, so I think that reproducible. So one obvious way to improve reproducibility is by really taking the time to do some documentation. Because all of the experiments with reproducibility show that there is always a number of questions that are coming up. So typically when you're trying to install somebody else's software, there's always questions about this has been running for 5 minutes, is it normal, or how long more should I wait? If something is running for 1 hour, is it expected or not? So trying to document things about what to expect in terms of running time, in terms of results that can be obtained on a shared data set, and so that's how shared data sets come into play. And so I encourage you to look also at the list of the 40 criteria that really detail step by step different things that can be addressed. And I think also it's very useful to try to have someone else reproduce your experiments or your research by just like having them redo a whole pipeline of experiments, and if needed, sitting by them as they do it. And this way you can also understand what questions they have and use that to make useful documentation, because it's likely that the questions that your colleagues have, other people will have as well. And as a developer of a system, you're so familiar with what you've done that it's also sometimes difficult to have the hindsight and the understanding of what is going to be difficult to a newcomer to the situation. So I hope these are a few elements that can answer the question.
Sí. There is another question about the concentration of data and computer power by large companies and the impact on democracy.
Well, that's certainly a very important question at the moment. And so that goes beyond, I think, just the field of biomedical natural language processing. And I think it shows that these discussions about ethics need to be open in the community, and we need to have our voices heard about the different concerns that come up, such as these ones. And I don't know if you have seen that recently. So the ACL has circulated a survey about the use of computer power by researchers in their experiments, and so trying to understand something a bit similar to what you're asking here, trying to understand the access of researchers to computer power and how limiting or the access or lack thereof to these computational facilities is to researchers. And so I think it's important that the community is looking at these aspects, and I'm looking forward to the results of the survey.
Totally agree. So there is a comment by Leonardo. Are you reading the chat?
Yes, so I see that Leonardo is saying that his group has recently made available a Spanish corpus of abstracts and announcements of clinical trials, and so he's providing the reference to the data set. And he's asking, are there any official guidelines about reproducibility of experiments? Are the ACL resources you provided enough to follow? Well, I don't know if there are official guidelines. I mean, so as you've seen that the ACL, in fact, has put a questionnaire about reproducibility for the assessment of papers that are submitted to the ACL. So those, I guess, also give guidelines to questions that can be asked. So yeah, again, I don't. I guess this is a shameless promotion of our work that we did recently with trying to survey the literature about reproducibility, and I think that. Also, the criteria that we provide are quite comprehensive. And when you're looking at experiments, maybe looking at this grid of criteria and the 5 different aspects, and trying to see a bit like we did in the evaluation of systems, which criteria are met by your protocol or your tool, can maybe be a way of trying to understand how compliant with these desideratas you are, and if you are, I think that would be brilliant, because at the moment I don't think anybody is able to do that. So. So Matthias is saying, I feel very identified with the reproducibility issue. So he said, recently I replicated about 6-7 existing NER experiments for my research. Unfortunately, due to lack of documentation and errors in code, it was complicated to reproduce all of the systems in the Chilean dataset. Could the problem be related to a lack of reproducibility filters by paper reviewers at major conferences, and how could this be improved? Well, so I think that one of the problems is that reproducibility is, I think it's changing a little bit, but until recently, reproducibility wasn't really seen as a meaningful contribution, because it's not something new. You're just trying to do again something that has already been done. And I think we need to understand that this is something very important, and to advocate for its importance, and to give rewards to people who try to do that. So in the form of, first of all, crediting their efforts as being real research, even though they're trying to do something old and not something new. And there are some tasks currently also that are fostering this kind of thing as well, where the entire task is dedicated to reproducing systems. So that's, I guess, a venue for doing this kind of effort and finding additional documentation on the experiments that are being reproduced. And David asks, does reproducibility depends on the model, the neural model that is used? Okay, so this is another aspect of reproducibility that I haven't discussed in the presentation, but it's a very good question. So we also so there's a very good paper by Reimers and Gurevich from 2017, I believe, where they show that there is some variability inherent to some neural system just because it's a non-deterministic algorithm. So really, when you're comparing algorithms, you should be looking at the distribution of results and not the result of just the one run. So that's one thing that is that's important to know. And so that's why so robust experiments oftentimes show an averaging of several runs to well, I guess to approximate this notion of distribution. And in terms of reproducibility, so together with Kevin Cohen, we also thought about different ways of an experiment can be reproduced. So you can either reproduce the actual value of the results. So for instance, are you getting the exact same measure, F measure, as the previous experiments did? And so that's reproducing the value. But then sometimes if you don't reproduce the value, it's normal, because if you're using this neural system, you cannot always reproduce the exact same value, but are you going to reproduce the finding? So typically a finding is, system A is doing better than system B. So if you reproduce the experiment and you still get A is doing better than B, even though it's not the exact same numerical values, then you're still reproducing, the experiment. And then there's also the level of conclusion, where sometimes you find values that are significantly different, and that's not always explained by the model itself, or not only by that. There's something going on maybe in the pre-processing because it's not documented enough, and you don't really know how to pinpoint it. And but sometimes you're still able to reproduce the general conclusion of how you interpret the experiment. So these are the different levels. So David is asking, so can repetition adjust the model? I don't think it's adjusting the model. I think it's giving you I think it's giving you more data points, because by having just a single run, you cannot approximate. I mean, a single run is a bad approximation of a distribution, basically. So if you do several runs, then you get a better approximation of the distribution. I think that's how I would look at it.
Well, and adding that the problem of running many times some models that are very heavy is sometimes not possible. I mean, if you take in 10 runs 2 weeks, you are not able to run every part of your model many times. Mm-hmm. That is a challenge.
Yeah, so there's this, and there's also some contradictory, I guess, goals, because if you want to limit also the environmental impact of the models, you don't want to repeat experiments too many times either. So it's a bit, it's really difficult to balance everything.
And I think related to that, like when you talk to someone from deep learning community, they tell you like, no, we run once because it's too heavy to run more than once. But if you come from maybe a biomedical background or whatever, they say, no, you have to run several runs and maybe report standard deviation and the mean of the value. So I think that there is maybe a clash between two kind of communities that report in different ways.
Yeah, and I think it's really important to really get a broader perspective. because if a model is so heavy that it takes a very, very long time to run, and it also takes probably a lot of skills that maybe doctors do not have to install it and implement it and run it, then maybe that's something to take into account. Also the criteria of explainability of the results as well. And it's important to have a broader view.
Mm-hmm. And Aurélie, I copied from the YouTube channel. So Vera asked if you can comment on this or on any of these topics, body informatization, individual autonomy, and social exclusion. I don't know if you feel that you can add.
Yes, because I'm not sure I'm familiar with the notion of informatization of the body. So refers to the ability to extract a large amount of information about an individual from biometric systems. So one comment I have on this. So there's a group called LISN. It's I'm not so it's language in the machine learning era, something like that. I think that's what it stands for. And so they are so thinking about these issues about so more around the notion of language rather than body, but there are things about the enhanced language issue. And thinking about a number of different implications from legal perspective to social perspectives, etc. And so they wrote a whole I guess it's called a white paper or a big document with thoughts about that. So I can provide the reference if you'd like to look into this issue much deeper.
So there is another question. I don't know if you finished with that or you want to add something.
Yeah, I see that. So Pablo is asking about, can you comment a bit more about the workflow management system for French clinical NLP? Is it a future idea or is it already implemented in a clinical setting today? And do you have recommendations to transfer this type of architecture to other countries, considering the ethical aspects? Yes, so to comment about that, so that workflow is, so our colleagues are in the Paris hospital, so they have implemented this in their hospital. It's still so they're testing the architecture. And the good thing about that is that the architecture itself is not proprietary or linked to data in the hospital. It's really intended to be filled with the specific annotation tools or data or what is available. So they have a GitHub repository actually with the Python library that implements this. So I can find the reference and share it if you'd like. And and I think it can definitely be it can be used in other settings as well. And so the notion is to really have an architecture that facilitates the creation of workflows for clinical NLP, where you can just plug in whatever components are available to you in the different parts.
And I have a question. So I feel that, NLP is done by academics, but also by companies. And also there are so many theses and projects going on that people try to implement a support system for clinical decisions. And So it's kind of everywhere. So it's hard to, like, from a central unity, try to control or trying to make guidelines, because the access of the ACL is also unequal. Like not everyone is going to the conference, or not everyone is reading the paper. So what do you think that we could do as a community? Like, do you think that we should try to train certain people in certain countries and say, okay, can you go and give talks about reproducibility and ethics in NLP? How do you imagine that, like trying to transfer from the paper and from the conference to like the actual practice?
Well, that's a good question, and the field is really becoming, I think, quite huge. So it's it's difficult to keep up with everything that's going on, like you said. So there is an initiative by different working groups are trying to do this effort of trying to keep up with the literature and search. So for instance, there's the Yearbook of Medical Informatics. So I don't know if you're familiar with that. And so every year, so there's a clinical NLP section, and they do a year in review of the literature on clinical NLP. So these are good venues to get an idea of what are the recent topics that are addressed by the research community. So that's outside of the ACL. And as for talking about reproducibility and ethics, I think there have been I think tutorials about ethics in NLP organized by the ACL, so around the ACL conferences. So those are good venues to be informed about these things. And then I'm not aware of specific efforts to foster the reproducibility of specific pipelines or tools other than those that are done with the researchers that are developing the methods themselves. So that's still an open question, I guess.
Mm-hmm. Yeah, and especially in a field that has so much attention, that there are so many conferences and things going on, that I think it's hard to try to make official guidelines, and that those are transmitted to the people that are actually doing things sometimes outside the academia. So, Is there any other question? I see, it seems that there is no more questions in the YouTube. And I just got to know that we have been 1 hour and 20 minutes. So sorry, for the people that thought that was shorter. And sorry to you, Aurélie. So I think with that, we can say goodbye, and thanks again to Aurélie and to everyone who got this talk. The people from Spain that are here as well, thank you very much.
Okay, well, thank you for the invitation, and well, thank you for all the very interesting questions and for your interest in the topic.
Thanks, and bye, and thanks to everyone.
Bye.
Bye, thank you.
Thank you,
Bye.
bye.
Merci beaucoup, Aurélie.
Merci.
Au revoir.